today's lesson is on dividing a polynomial by a monomial. As usual, there is a video guide to go along with this lesson. If you have not printed it yet, go ahead and pause the video, go print the video guide, and then come back and you can work these problems out with me. Alright, so dividing a polynomial by a monomial. We've done multiplication, alright? Division's actually not that much different. We have 3 steps that we're going to talk about that you need to go through each time you do a division problem for polynomials, and then we'll do some examples together. So quick reminder, remember a polynomial is, poly means many, so a polynomial has 2 or more terms, and then we're dividing that by a monomial. Mono means 1, so monomial means 1 term. Alright, so we're dividing 2 or more terms by 1 term, and for our practice today we're just going to get up to 3 terms at a time. So for division, we want to divide each term, that's our first word, we're going to divide each term in the polynomial by the monomial. It's very similar to the distributive property, just with division, not multiplication, okay? So each one has to be divided, all right? Make sure you don't leave any of those out. For B, our next step, we have, we're going to divide the coefficients. That's a word that we've talked about before. Remember, coefficient is just the number in front of the variable, all right? So, number in front of the variable are whole numbers. For us today, those are just going to be whole numbers. So coefficient is number in front of the variable. For us, that's going to be the whole numbers. We're going to be dividing those like normal. It's going to be a division problem. Divide those front numbers. All right? Last step, make sure you subtract the exponents of like variables. So subtract x's with x's, y's with y's. And again, this goes back to a previous lesson where we were dividing terms that had exponents. Again, we took the top minus the bottom. Okay, we are going to do that same thing today. We're going to take what we learned about division with exponents, we're going to take the top exponent and we're going to subtract the bottom from it. So we're going to combine a lot of information that we already know into a new type of problem. Okay, for our first example, problem number 2, we have 30r to the 4th plus 50r to the 3rd plus 20r squared, and we're dividing that by 10r squared. Now, our rules say that we need to go ahead and divide each term. So again, I said this is a lot like the distributive property. Each one of these terms in the polynomial is going to be divided by 10r squared. All right, so we can go ahead and do each one separately, and then our answer is just going to have all 3 terms after they've been divided. So what we have to do is go ahead and divide the coefficients. Start with 30r to the 4th divided by 10r squared. If you want to look at it this way, we're doing 30r to the 4th. We're dividing that by 10r squared. After that, we'll add to that the 50r to the 3rd divided by 10r squared. And then after that, we're going to divide 20r squared divided by 10r squared. All right, so we're doing each one separately. All right, so start here, divide the coefficients. So we're taking 30 divided by 10. This fraction means division. Okay, they're not necessarily going to use the regular division sign. All right, using a fraction, it means the same thing as divide. So 30 divided by 10 is 3, and then they're subtracting the exponents. Remember, we always subtract top minus the bottom. So we're doing 4 minus the 2. So we have r to the 4 minus 2, which is 2. So it's 3r squared for our first term. Bring down the addition sign, okay? Divide the coefficients for the next term, okay? So we're going to do each one separately. So 50 divided by 10 is 5. Subtract the exponents, top minus the bottom. So this is going to be 3 minus 2. 3 3 minus 2 is 1. So this is r to the first. But remember, anything to the first power is the same thing as just having the letter. So it's just r. Okay, you can write it as just 5r. And then our last term, we have our addition sign here. Divide the coefficients. 20 divided by 10 is 2. And then subtract the exponents. 2 minus 2 is 0. Now remember, any variable to the 0 power means that variable no longer exists in that part of the problem. So we don't have any r's in the last term. They've canceled out. So our answer for problem number 2 is 3r squared plus 5r plus 2. That's it. Let's look at problem number 3. We have 16b to the 7th, and we are going to divide that by 8b to the 3rd. Add to that, we have 24b to the 5th, and we're dividing that by 8b to the 3rd. Subtract from that 64b to the 3rd, and we're dividing that by 8b to the 3rd. Again, each term in the polynomial is being divided by the monomial. So we can go ahead and do our division for the first term. Let's divide 16 divided by 8. We get 2. Subtract the exponents, top minus the bottom. 7 minus 3 is 4, so we have b to the 4th. All right, use our addition sign. 24 divided by 8 is 3. Subtract the exponents. 5 minus 3, top minus the bottom. 5 minus 3 is 2, so we get b to the 2nd. Use your subtraction sign, do the last term, okay? 64 divided by 8 is 8. And then for your exponents, 3 minus 3 is 0, so that means there is no b in that last term. So our answer is 2b to the 4th plus 3b squared minus 8 for problem number 3. For problem number 4, we have 16x to the 5th minus 20x to the 4th plus 5x to the 3rd, and we're dividing that by 4x squared. So let's go ahead and rewrite this. We're taking 16x to the 5th divided by 4x squared minus 20x to the 4th, and we're dividing that by 4x squared, plus 4x to the 3rd, and we're dividing that by 4x squared. So let's start with our first term. 16x to the 5th divided by 4x squared. 16 divided by 4, divide those coefficients first. 16 divided by 4 is 4, and then subtract the exponents. 5 minus 2 is 3, so we get x to the 3rd power. Subtract from that, do your division. 20 divided by 4 is 5, and then subtract the exponents. 4 minus 2. 4 minus 2 is 2, so we get 5x to the 2nd for our second term. Then divide the last. We have 4 divided by 4 is 1, and then subtract the exponents. 3 minus 2. 3 minus 2 is also 1. Remember when we get x to the first? That's the same thing as just x, so we don't need that. Also, notice my coefficient is 1. 1 times x is just x. So I don't need that one either. So the way that they are going to write this in simplest terms would be 4x to the 3rd minus 5x squared plus x, just x. No 1 in front, no exponent of 1. They would only write x. So this is our solution for problem number 4. Problem number 5, we have 12n to the 5th minus 42n to the 3rd minus 12n. We're dividing that by 6n. So let's go ahead and take our division to each term separately. So 12n to the 5th divided by 6n. We're subtracting from that 42n to the 3rd divided by 6n. And we're subtracting from that 12n divided by 6n. Okay, so each one's being divided by the 6n. So first step, we need to divide the coefficients. 12 divided by 6 is 2, gracious. 12 divided by 6 is 2, and then we subtract our exponents. If there is no exponent for the n in the denominator, remember, that means there is a 1 there. They just didn't write it. So let's go ahead and put those 1s in. So we're going to subtract 5 minus 1. So 5 minus 1 is 4, so we have n to the 4th. Bring down our subtraction sign. Divide for the second term. 42 divided by 6 is 7. And then we subtract our exponents. 3 minus 1. Always the top minus the bottom. So 3 minus 1 is 2, so we get n to the second. And then for our last term, we've got our subtraction sign. 12 divided by 6 is 2. And then we subtract our exponents. This n doesn't have an exponent either, so we put the 1 there. 1 minus 1 is 0, which means the n's cancel. So we are just left with the 2. So our answer for number 5 is 2n to the 4th minus 7n squared minus 2. So at this time, go ahead and do the next two problems, 6 and 7. Work those out on your own and then come back to the video and I will show you the answers and how I got them. For problem number 6, we had 36x to the 8th minus 18x to the 6th plus 45x to the 4th, and we're dividing that by 9x to the 4th. So I went ahead and separated each term, knowing that I was going to divide each one by the 9x to the 4th. So 36x to the 8th divided by 9x to the 4th gives me 4x to the 4th. I divided my coefficients, subtracted my exponents top to bottom. After that, my subtraction sign, 18 divided by 9 gave me 2. Subtracting 6 minus 4, I got a 2 for my exponent as well, so I have 2x to the second. And then for my last term, 45 divided by 9 is 5. Subtracting my exponents, I got 0, which means my variable is no longer in that term, so I'm just left with 5. So our answer for number 6 is 4x to the 4th minus 2x to the second plus 5. And then for problem number 7, we had 28k to the 6th plus 35k to the 4th plus 56k to the 3rd, and we're dividing that by 7k squared. So I separated each term and then I did my division. So 28 divided by 7 is 4, and then subtracting the exponents, I got a 4 for my exponent as well. So 4k to the 4th, and then my addition sign. 35 divided by 7 is 5, and then subtracting my exponents, I got a 2, so I have 5k squared. And then my addition sign. 56 divided by 7 is 8, and then 3 minus 2 is 1. Remember, if the exponent is 1, you don't need to write it, and they won't write it for like a multiple choice answer. So our answer for problem number 7 is 4k to the 4th plus 5k to the second plus 8k. And that's the end of our lesson on dividing a polynomial by a monomial.